Hello, beautiful brains. Welcome to the family of Maths Fanatics. Today we're going to be looking at this question on probability taken from 2019 Paper 1 KwaZulu-Natal Preliminary Examination. Okay, without wasting any time, let's get straight to it. So on question 12, we are given a bag that contains 12 blue balls, 10 red balls, and 18 green balls. Okay. So how many balls do we have in total? Let's see. 10. If you go to your calculator, you say 12 plus 10, and then you add 18. That should give you 40 in total. So we have 40 balls of different colors in a bag, basically, right? Okay, let's keep on reading. 2 balls are chosen at random without replacement. Okay, now, guys, remember I said when you read a question, you should know what kind of a question it is. For example, here I already know that this is a tree diagram type of a question. I have to draw a tree diagram to be able to solve this question. How did I know that it's a tree diagram question? There are 2 events that are happening here. We draw the first ball and then we draw the second ball. So always remember this. If there are 2 or more events that are occurring, you always use a tree diagram to solve such type of questions. So now, let's get straight to it. So I'm going to construct my tree diagram based on the given scenario, right? I'm given 3 different colors here, right? So I have to have 3 branches, right? The first branch is blue. The second branch is red. The third branch is green, right? Then I'm gonna have more branches here because they were drawn twice. There were 2 draws, right? Sharp. So this is the first draw. This is the second draw, né? We're gonna have blue, red, and green. We're gonna have blue, red, and green. We're gonna have blue, red, and green. Okay. So we have red up to so far. Then they say they are chosen without replacement. So without replacement means the total of balls here will be 40, right? And then here the total of balls at any given draw will be 39 because we had 40 balls and then we made the first draw and not replace it. So it means we're going to have 39 balls left. Okay, let's represent the probabilities on the branches. You always represent your probabilities on your branches. So I have 12 out of 40 because there are 12 blue out of the total. I have 18 red over the total. And then I have what? Oh, sorry, this is a mistake. So the red are 10. So I have 10 red and 18. 18 what? 18 green, right? So over 40. Perfect. Now let's go to here. So if I chose blue as my first option, it means I have 11 blues remaining. The other parts will still remain the same, right? It's gonna be 10 and 18 there. But now we have over 39 because we did not replace, right? So over 39, perfect. If I chose red as my first option, when I was picking the first time, it means I have how many reds? I have 9 reds. This one will still be the same, and those ones will still be the same. Then out of 39, so this is 18, eh? 9 out of 39 out of 39 because there's no replacement. Okay, if I choose green as my first option, it means I have 17 greens left. So I have 17 out of 39. Then this one will remain the same. So here I will have 10 over 39. Then here I'll have 12 out of 39, right? Then that's my tree diagram. after drawing a tree diagram, I am now sorted, right? Let's set up our solutions now. So on 12.1, they want us to determine the probability of 2 balls chosen at random being green. So they want P green basically, right? So P green, obviously, the first one is green is here, and then the second one is green here, right? So I just have to multiply the probabilities of this green and that green. So the first probability of picking a green was 18 over 40 multiplied by 17 out of 39. Let's see what does this give us. So we have, let's see quickly. So we have 18 over 40 multiplied by 17 out of 39. This gives us what? 51 over 260. And that should score you your 3 marks there. Okay. Now let's check this one. The second question, what do they want? They want us to determine the probability if 2 balls chosen at random are blue and red. Blue and red. They didn't give us the order, you see? They said blue and red. So I'm going to check where I can get blue and red. Ne? Okay, let me use a different color so that we can see it. So the first option is going to be this one and that one. So from here to there, you see it. Let me show you. From here to there, and then from there to here. Do you see it? Sharp. I have blue here, here I have red, right? Then the other option can be this one. I have red here, and then I have blue there. So this will be my second option, right? So what we do here is this. So I'm gonna start with this part times that part. Ne? So the first blue is 12 over 40 multiplied by the red, which is 10 over 39. And then you see I'm at the end here. When I switch and come back here to there, remember I have to move from here to here. You add a plus sign, a plus sign. Because I did the first branch and then I got to the end, I have to now go back and come to this branch. When you have to go back and come to a different branch, you always put a plus sign, okay? So here I have 10 over 40 multiplied by 12 out of 39. Then let's see what that gives us. Okay, let's see what it gives us quickly. Okay. So I just want to erase this part here so that we can see properly on our calculator. Awesome. Okay. So let's see, we have 12 out of 40 multiplied by 10 out of 39 plus 10 out of 40 multiplied by 12 out of 39. That gives us how much? 2 over 18. That should be your other 3 marks. Then you're done with question 12. Now let's jump to question 13, okay? Now jump to question 13. Okay, let me get my pen. Awesome. So question 13, the digits 1 up to 9 are used to form a 3-digit code. So we need to form a code that is composed of 3 digits. So out of a pool of 9 digits, we just need to pick 3 to form a 3-digit code. Yeah? Think of these numbers as what? S fishes in a pond. You are just going to pick them randomly. Like you can pick this fish and put it here, and another fish, put it there, and so on to create a 3-digit code. Okay, now let's check. Determine the number of different codes that can be formed if repetitions are allowed. So if repetitions are allowed, let's check now. Okay. So for here, right, for the first part here, I have 9 possible options to pick. I can pick 1, I can pick 2, I can pick 3, I can pick 4, 5, 6, and so on, right? So I have 9 options here to pick from, right? But because they say repetitions are allowed, if repetitions are allowed, my options never changes. They remain the same because I can pick 1 and I can pick 1 again and I can pick 1 again. Does it make sense? So if repetitions are allowed, you always having the same amount of options. So I still have 9 options and 9 options. So it's 9 to the power 3 basically. Does it make sense? Awesome. So let's check here. Let's check what's happening here. I just want to get my things back quickly. Okay, so here we're going to have, okay, let's see. We're going to have this now. Let's check quickly. Apologies about that, ladies and gentlemen. So we have 9 to the power 3, which is 729. So the answer for this one here is what? 729. Okay, the 2 marks there. Okay, now let's answer 13.2. Now they say we need to determine number of codes that can be formed such that the code is greater than 5,000. And now repetition is not allowed. Okay, so let's check 1, 2, 3. So let's fulfill the first thing first. Ne? They say it must be greater than 5,000, which means here, but on the first position, I can start with 5, 6, 7, 8, or 9, right? So I have how many options to pick out of the total? I have only 1, 2, 3, 4, 5 options. So in a fish pool, right, of 9 fishes, for me to have 500, to have 500 and above, I have 5 options. I can either pick this, that, or that, right? Sharp. Now let's go to the second conditions. They say repetitions are not allowed. So remember here I didn't pick 5 options. I didn't pick a number 5, right? I had 5 options to pick from, right? So how many options am I remaining with? But remember at the end here, we're just going to pick one number. Out of these 5 options, we are just going to pick one number, right? This 5 must not confuse you that we already picked 5 options. No, these are just the options, but at the end, we're just going to pick one number. We can either pick 5 and put it here, pick 6 and put it here, 7, 8, and 9 and put it there, right? After picking one of these numbers, let's say, let me give you an example. Let's say, for example, we picked 6, right? How many options are we going to remain with? Because repetitions are not allowed, we are going to have what? 8 options to pick from now for the second part, because they do not allow repetitions. So if I picked 6, as in my example, I cannot pick 6 again. So I have 8 options now. So 8, and then whatever I picked, I cannot pick again. So here I'm going to have 7 options. Then you multiply those numbers. And that should be your answer. Okay. Let's check what our answer is going to be. So we have 5 times 8 times 7. Sorry, times 7. Which is 280. Okay, so here we have 280 possible options. Okay, now let's do the last one. They want us to pick the number of arrangements in such a way that the middle digit is 5. You see? So the middle digit must be this one. So in the pond of these fishes, I only have one option to pick for the middle, which is 5, right? So here I can only pick one option, which is 5. And then yes, repetitions are allowed. So if repetitions are allowed, you just count the total number of fishes you have. I have 9 fishes, so I'll always have 9 options to pick from on whatever spaces are remaining. So let's check now. Let's check what our solution is in this case. So we're going to have 9 times 1 times 9, which should be 81, I think. Yeah. Our calculator also gives us 81 possible codes that are going to form. I hope this makes sense. Feel free to leave comments in the comment section. And all the best, ladies and gentlemen. I hope this was really helpful. Right. We shall meet in our other episode of Mathematics. Thank you.